type. One is console IO, other one is file IO. This is the first topic today. Then type def, that part we'll discuss. Unions, I won't mention as such. Linked list I'm going to mention. Enumeration and macro, that part I will be discussing. So that's the topics for today's lecture. Let's start with file IO. So you understand this difference between this IO means console IO and file IO is that here reading and writing, this is done on a file. So this is done on a file. So here you see actually to the compiler, whether it is console IO or whether it is file IO, that doesn't make any difference because the console or this output screen itself, they are also considered as a file. Okay, and you know that to read or write, there is a concept of stream. Okay. So file IO streams are there. Okay, so that idea remains same. So only thing is they are also considered as a file. Now, what we mean by writing in a file? Okay. So let us go back to one of our previous slides where we discussed about memory, right? So where is our memory structure? Here. So up to this point, we have discussed about this part of memory, which is basically the inbuilt memory in the motherboard, the processor memory, and the RAM, which has some address and which are accessible by this CPU part. But when we are talking about this file IO, this file is something different than this RAM part, because you know there is another part which is a permanent memory, right? So this is what we have discussed there as external memory or the secondary memory. Up to this much we have discussed so far, they were internal memory. Okay. So you take a note that the data connection between these CPU part and this RAM part, they are very fast. Okay. Their speed is quite fast, almost instantaneous. But if we try to access an external or secondary memory, okay, there our speed that becomes somewhat slow. Okay. Now, you know, the primary external or secondary memory is a hard disk, which all of us have in this desktop or computer, laptop computer. And then further, we can store it in a CD, in a floppy disk, etc., etc. So when we are talking about file IO, we are talking about writing some data or reading some data from this secondary external memory. This is clear. Okay. And what else? And another thing is this is RAM. This is not the thing. This is what we are talking about. Okay, the permanent memory, like our library. And these are the file structure of a hard disk. Of course, you know that this particular shape of a hard disk, like a circular one, like tracks and sectors, and there are some stylus which moves in this direction, like a gramophone record. It takes a lot of time and its operation speed is slow, and so that is why nowadays solid state SSD uh, hard disks are being used. Whatever, that is not of interest to us. What is interest to us is the file structure of this hard disk. So these are some of the things given there. There are root directory, there are then uh, some more divisions under each, there are some more divisions, so on and so forth. Okay. So this is about the memory structure, and this is where we write our data. So if you like to know where is that memory, where is that file structure, I think all of you use Windows operating system. There you have this icon. This particular icon is your uh, file explorer icon. Okay, there you go in the very root, and in the very root, what you will get is usually there are 2 or 3 partitions. This is my laptop where I have only 2 partitions. Okay, so usually, if you use a desktop, you might get a C, G, and E. Now, these are the root directories, right? So, by default, the C directory contains all the executable files or your program files. Now, this disk E is used for the user, specific to the user. And when you have a D drive also, there you can keep some files which are not user specific, not belonging to a program file, etc. So this is fine. And then you subdivide it. Okay. Further, you divide it. You see, these are some of the divisions. Then again, let us see what are the subdivisions. Right here, this particular coursework CPNM is here. This and that thing. So here codes, this one. So that way, whatever the thing, you have some idea about file structure. Now you see, even without reading or writing a file, if we run a C program, okay, or say if we open a file from where it tries to open the file, this is the same directory, the codes. Probably you cannot see this thing. So this codes is known as, it is the same file structure. That means, as I have shown you, this is the codes. Okay. So within CPNM, I have a directory codes. So this becomes the default directory for reading and writing But you have the option of changing this default directory as well. Okay. So what is the specification of a file now? So you see, the complete specification of a file is the name of the file. So here add and subtract. This is name of the file. Next, it comes the type of file. .c represent it is a C program file or C code file. And then you see this particular file is located within a directory which is code. This code is again located within another directory which is cpnm, and then it is under class notes ug, right? So, and if we go on that way from class notes, uh, what else we'll get? Ultimately, we'll come back to this E drive. Okay. So this is the root. So to specify a file, first you have to specify the directory where the file is located. Next, you have to specify file name and the type of the file. And this is clear. Okay. And this particular specification is necessary for our reading or writing in a file. What happens for console IO? Here we have two files, input and output file. Input file is this keyboard. The output file is the screen. But you understand the situation is somewhat different in file IO. Is clear. Now this the other parts like this placeholders, okay, the for different formats the placeholders remain same, whether it is console IO or file IO, they remain same. And although there are some more functions for console IO, we have used printf and scanf only. Is it okay? We haven't used any other inbuilt functions. So that is what we will be doing for file writing also. So what is the difference in, okay, in file writing and console writing? We had scanf printf for console IO. So this scanf and printf will be replaced by f scanf, and then we'll have a f printf. Okay. We'll have a f printf as well, f printf. Okay. So we'll be using these two only, although there are some other functions available. Let us not focus on that. So to understand, like scanf, fscanf is used to read data from a file. And like printf, fprintf is used to write data in another file. Okay. So now in connection with file operation, there are some more options which we need to specify. Okay, so these are the options. So When we open a particular file, we can specify what we are going to do with that particular file. If we are going to use fscanf, then obviously we are going to read something. So here that option is R. Okay, for the purpose of writing, we use this W option. Okay. Now it is also possible to append. Now what happens in writing, if there is an existing text file, the writing will start from the very beginning. So whatever information was there in the file, it will get lost. So in such cases, we can use A, which is append. That means the existing data, it remains there. And from the end of that part, fresh writing starts. Create text file for writing at the end of a file. So here, in connection with this, we require some more comments. Those two primary comments are fopen, right? So what fopen does, it opens a file. What is the argument of fopen? This argument is the file name. Here again, you understand that file name you should specify completely, starting from the root. Or you may omit that also. In such case, you have a default directory, default working directory. So your file will be opened in your working directory. This is clear. You have to specify a file name. Okay. So when this is the first operation we need to do before any file IO, because subsequent fscanf, fprintf, that would take place in this particular file, which we are opening with fopen. Right? Now, take a note that it is possible to open multiple files. Okay. We can open a file name 1, file name 2, file name 3, etc. And selectively, we can write some data in some of the files. Now, what next? When that file operation is complete, we must close that particular file. What does it mean? So this data which is there in this particular file specified by file name is accessible to the compiler. Now when it is closed by using fclose, then only the data within this file name is stored, it becomes secured. So if you exit your program without closing a particular file, there is a possibility that you may lose data or you may collect some garbage. Or sometimes it may so happen that you get the required result, nothing has happened. But you must not take that chance. So whenever you open a file, use a corresponding close command. So those are fopen and fclose. So this is additional part for file IO. Now these functions we are not going to use. So fopen, fclose is necessary. And in addition, there is if close, yeah, this one. This is sometimes becomes very useful. So this gives us the end of file. Okay. So why this is necessary? So sometimes when we are appending in a file, before writing, we may check whether we have reached at the end of the file. Another application, if we try to read from a file, what is the data available in that particular file is not known a priori. So there we can make a checking whether this end of file that that marker we have reached. So that is accessed by FEOF function. Right? So this is also a useful function in connection with file IO. Another one is the rewind function. The rewind function, what it does, from any point in an open file, from any point, if we use rewind of that file, it goes back to the very beginning of the file. And subsequently, it starts writing from there. So whatever data was there, that would get lost. And sometimes this is unnecessary. Okay. So this rewind function, FEOF function, okay, this fopen, fclose functions, these are necessary for file writing, for reading and writing files. Okay. So this is the thing. And all the other parts, whatever we'll write or whatever we'll read, that part is identical with our SCADF and printf. Okay. So let me see. What are the examples we have here? Say using fprintf, let us see what it is. So you see character term. Now, okay, let us see what is there. Now this con.io, console.io, this header file, I think would be necessary for your file input output. Anyway, you check it. Might be it is necessary. Whatever. Now the file, first of all, a file pointer is created, right? Understand that this fp is a pointer variable. And what is the type of that pointer? This is file. This is clear. So fp is the pointer of a file. Now, here this pointer means this is the address, but not that conventional memory address we have seen. It is basically contains this particular location of the file. Hmm. So it is like this. You understand, this is the complete path name. And finally, this is write mode. Okay. And what next? So file is opened. That open file is pointed by this pointer fp. So when we write in that particular file, we refer it by fp. Okay? So we could have make three such pointers: file fp1, fp2, fp3. Okay, and then also we should have specified fp1, fp2, fp3, and we could use fprintf for fp1, fp2, fp3. Okay, let us see what happens if we run this. So whatever details saved in file, that particular file is data 5, right? So where is our data 5? This is data 5. Hmm. So this is what we are getting from this particular fprintf. Understand? This is given, say roll number 290, name is Niels, and marks is 84.69, which is gone there. So this is an example of your fprintf. Now similarly, from a file, you can read data also using fscanf. Okay, so this is about our file IO. Okay, anything more you require on this? So this is what we have already discussed. So any question on file IO? So okay, I think you could understand this thing, or you study it yourself, you will understand that. Now the next part is this type def, right? It is there. Okay, here, what is the purpose of type def? It is used to define new types. New types means not new types. It creates actually a new aliases. as the types means data types. Okay, it cannot create a new data type because there are some inbuilt data type which are primary, then there are secondary, etc., and user defined like structure. So that cannot be changed by type def. So type def is used to define not new types, it is used to create a new aliases for a particular data type. This is the thing. Now, type def, this format, type def description name. This description is the description of data type. So let us see an example. Say type def int units. Okay. You see, type def description means this is the data type. So it can be int, float, whatever, even structure, whatever. This units is the name, or this name is the alias of that particular data type. So this unit stands for int data type. As you see here, instead of writing int millimeter, centimeter, etc., what we have written is units, millimeter, centimeter, etc., etc. Okay. Then we are specifying its value. So this is the common use of type def. Okay, type def can be used on the strings, other things, many things, on structures as well. So this is basically the use of type def. Now there is another one in connection with structure type, not type def. There are union. So union is supposed to save some memory. Okay, and previously we have seen that there are some problem with memory alignment, right? Here we discussed about that. Okay, about the members of a structure, how memory locations are aligned. So sometimes it requires a more memory space in this particular example. So in such cases, units are, it is not units, what it is called? Unions. Unions might prove useful. Although I haven't seen much use of that unions, okay, it has associated hazard also. So whatever. This is about our type def. The next one is our macro and enum. But this macro, you see, we have already specified macro when we were discussing about the C preprocessor. Here, you see. This is the general structure. So here we have the source file, our code file. Then there are header files which we might include there. And in addition, there is a preprocessor part. Okay, this preprocessor is not part of the compiler, separate step in the compilation process. So like header file, we can create our own macros. So the C preprocessor, in addition to header files, if they are used, they are called the macros. Okay. So some example of this macro is given here. See, really a header file is specified by hash include, right? And a macro, this is initiated by this keyword has defined. Right? So has defined starts a macro. Within that, whatever is there. So within this has defined, these are some of the functions we can use within a macro. Those are this undef. This is something different. If there is already a macro, that can be cleared by undef. Okay. So it nullifies the definition of a macro. And then if def is a checking that whether a particular macro is there. Okay. Now, and connected with this is if not def, if ndef. So this is the same thing almost, but anyway, this is available. Has if, has else, they are available in the definition of a macro. So if is there, else is there, elif, else and if in one statement is there, end if is there, and error is also there. Okay. So error message is not part of our definition of macro. We might use error, but this can be used separately. And another special use is this pragma, whatever. So these are the uh, functions we can avail in defining a macro. Of course, this is not including the header file. Header file is a different part, and macro is what we are creating. Okay. Some example of macro here has defined max array length 20. This means subsequently this max array length, this would be replaced by 20. So let us see this example. See this macro. Here, see, the square of a number x, this is defined within a macro as x multiplied by x. Okay. So what will happen within the code, somewhere we get this square of x, then it will be replaced by here, or it will be replaced by there. It will return this x into x. Okay. Now, here I think in defining a macro, that data type definition is not, that option is not available. So that we have to be careful while calling a macro function. So this is a macro. Something more is there. So macro is initiated by, has defined preprocessor. This we have seen. Next, macros with arguments. See, this is a particular definition of macro. Let us see. Here, slices is a macro. Its value is 8. So as such, it is not a macro. It's a definition. Okay, some variable or whatever you can say. This is 8. Now, another macro named add is defined like this. Now, what happens here? A is 0, int b10 c6, and add b plus c means what? B plus c is 10 plus 6, 16. So add 16. So add 16 means 16 divided by 8. Okay, so it will return 2. Okay. So this will return 2. But whatever, this is quite clear. But sometimes using macro creates a lot of problem due to data mismatch. Because you see, in defining a macro, there is no scope of specifying data type. You have to be careful while calling that particular macro. So, but this is the use of macro. So this is not for the novice users. So for expert users, they use macro for their convenience, and it becomes much useful in some situations. So this is what is known as macro. And enum, okay, enum means enumeration. Okay. So when you use enum, that means it will enumerate. It will enumerate starting from 0. Okay. And it will run depending on the number of elements present in this list. Right. So here, say let us enumerate week. So what does it mean? Week 0 is Sunday, 1 Monday. You understand? They are enumerated as 0, 1, 2, 3, 4, 5, 6. Okay. Following by 1. Right. So this is how enumeration is used. This is creating an enumeration. Let us see if we have an example. Here is the example, but then you see this is the default. Okay. Enumeration would be from 0 to 6, but this can be overridden by the user assignment. So that way we can use Monday 1 and Sunday 7 explicitly. This is also allowed. This is an enumeration for colors. Red will become 0, orange 1, etc. Let us see. Month is there. Now, follow this code. I equal to January, I less than equal to December. What does it mean? So now this January to December, they are taking values 0, and of course it will be 11. But it is printing I. So you see 0 to 11, right? And then from Monday to Sunday, it is printing days 2, right? So anyway, this is how enum or enumeration works. Another example is, say, previously you had a problem where you had to find out the next day from the given day. There can be another such problem where given a day, you have to express the day in terms of its date, month, and year. So you understand this 22 or 721 will be expressed as 22nd July 2021. So in such cases, we require enumeration. So this is about enumeration. Okay, and this is something about command line argument or CLA. So although I do not know about CLA, but the idea is like this. Whenever we use main, is there any main here? Yeah. So far, we used main with a void space here, right? we had a open parenthesis and closed parenthesis. But by default, it has two arguments. Those two arguments are one is an integer type, it's called argument C, argc. Another one is a character pointer, which is argument V. Now, with these two arguments, some more processing can be done, right? So, so this is what we are, at least I am not familiar with. But the thing is, we are executing a C program directly from this compiler, okay? So it compiles and runs. But then there are other compilers where this compilation and run, they are not connected with each other. So there one of the step is compilation only. So after that, compilation, it creates an obj or object file. Then again, it creates an executive file, .exe file. And that particular file can be run by using its file name. And at that point of time, it is possible to provide those two arguments while running that particular program from command line. So you understand what is command line? We are not familiar with command line nowadays. Okay. So here, if you write something here, okay, this is a much equivalent to writing something in command line. But to understand that previously, when we had earlier versions, say DOS or still today, if you use Unix or other versions, you won't get this particular window, okay, and the icons for each command. You have to use everything from the keyboard itself. So you have to use this command line to execute your program. Okay, whatever macro enums ELA. So these are the things, okay, which I had to discuss. Something more is there. And another thing is I have sent you it's our C graphics. Now I think all of you have got these files, right? These are the files related with C graphics. Right? So, you see, first thing is how to install this part, C graphics. This is given here. Okay. I have to follow this particular procedure. And then you will get this graphics facility in your compiler. So that part you try to explore. Okay. And then report me back what is your finding. So that's the thing. Okay. So next on Thursday we'll have another test, test 2. Might be we have no, actually we have a third test. When is the end of your sessional classes? First week of August, right? Hmm? No, I am not hearing you. In that case, in the next week, there would be 2 lectures. Sorry, 2 tests. Test 2 and final test, right? What are the dates? Today is 24, so that would be 29 and 31. Or I think in the next week also you can take the third test. Okay. So that next to next Thursday. Okay, that is better. So your next test would be up to control statements, right? Starting from IO to control statement, and the final one would be will include C functions to this macro enum, whatever rest is there. Okay, so this is what we'll do. Okay. Huh? Okay, so that's all for today. Let's stop here.